Today's topic is a bit more advanced because it steps into the realm of calculus. But don't worry if you don't know any calculus. I've planned this video out in a way where you don't need to know anything. So what is instantaneous velocity? Let's imagine you have a beautiful car and you drive it for 2 hours at an average velocity of 60 kilometers an hour. That's cool. We know the average velocity, but surely during this trip you speed up and you slow down and you speed up again. How do you find your speed at one specific moment in time? That is instantaneous velocity. Give you a conceptual example. So let's draw a graph. Let's say here's your distance traveled in kilometers and here's your speed. Let's say your car, you travel, you go really fast, you slow down because there's traffic. How do you find your instantaneous velocity? We can easily find the average velocity throughout the entire trip. But we don't want average velocity. What if we wanted to see how fast we're going at this moment in the trip? The concept of instantaneous velocity is that you zoom in on an infinitesimally small time interval. And you zoom in so much that you manage to capture one instant, an infinitely small amount of time. Your average velocity in that super small time interval is your instantaneous velocity. In maths, this is called the derivative. So if you've already learned about derivatives, then this might be more intuitive. If not, it's okay. Now to expand on this concept, imagine a car speedometer. As you drive, it's going to update. It's going to change. And how is it constantly updating your speed? It has to take your instantaneous velocity right now and then update it. So that's a real world application. Now here's the mathematical definition, or I guess the formula. Your instantaneous velocity is equal to limit t approaching 0 delta x over delta t. Don't panic if you don't know limits yet. I'm going to explain this notation. This just means that you should evaluate this fraction here as t gets closer and closer to 0. So obviously, as t approaches 0, it becomes instant. And quick note, if an object moves at a constant velocity, then the average velocity is the same as the instantaneous velocity. Makes sense, right? Obviously, if the speed is changing throughout, then no, it's not the same. Today, I'm only going through one example because I believe understanding the concept is far more important than understanding how to solve these problems. So I'll give you an example and we're going to solve it together. You drive your car down a straight highway and you speed down the highway. It's really fun, but you want to find how fast you're going 2 seconds after you pressed on the gas pedal. Your car's position in meters is given by the function xt equals 5t squared plus 2t. Let's go through this together. So remember the definition. It's limit delta t approaching 0, delta x over delta t. And really quick, we have to define delta x. Delta x, we will define it as x t plus delta t minus x t. What does this mean? Now this is taken from the derivative definition, but don't worry if you don't know derivatives. So here delta t is our super small time interval that we're using. So this equation reads as x at time t plus a super small time interval subtracted by xt. And we know t is 2 seconds. We're looking for it at 2 seconds. So delta x is equal to x 2 plus delta t minus x2. Let me make some space. Velocity is equal to limit delta t approaching 0. And now here's a part where it's easy to make some mistakes, but really we're just plugging everything in. Take this, your function of x. Take this and plug it into this. Our first term, so we're going to be writing this part first, is 2 plus delta t squared plus 2 plus delta t. there's our first term done. Now we have to plug it into this part. So I'm going to rub some stuff out, make some space. Remember, it's minus and then 5 2 squared plus 2 times 2. And all of it is divided by delta t from up here in the definition. Now when you go ahead and expand all the brackets, solve all your things, cancel stuff out, the answer comes out to be 22 meters per second.